Okay, so this is the first video on this networks project, and the first assignment is to come over here into files and look at this intro networks.rmd. This is actually something I did this a couple of months ago, and it's been a while since I've even really looked at it. So you'll see me kind of maybe screw up here a little bit and um, maybe not get through it as smoothly as I could, but that's all right. So the first thing I want to do is just load in these packages, and the new ones are this iGraph, which is this iGraph really is the package used to analyze networks. And it's even like a lot of our software, it's even standalone software. You don't the one of its implementations is in our package, but there are many other versions of iGraph. This Viz network is for doing the diagrams, visualization of the network, and that's less. There's many of these, and this is not necessarily the best, or it was just one that I think is pretty simple and creates nice and interactive visualizations. And I think we've used all the other ones. So network analysis is it's a quantitative approach to uh, interconnections among individuals. And in fact, I went ahead and yeah, so you'll see these kind of diagrams where these are like individuals, the circles are, and then the lines here are the connections between them. And they could be friendships between people. It could be, I've seen airports analyzed with this kind of network analysis where the lines could be, flights that go between those cities. Um, uh, I've seen network, like internet network analyses where these are, important internet connection points, and then they're the cables, and the satellite connections between them. We're going to be talking about it more in terms of social networks and, friendships between people, or people that are following other people on Facebook and that kind of stuff. So the first kind of introductory data set that I want to use is contained within this terrorist nodes. And so if you come over here to the files, it's this terrorist nodes and terrorist links. It's not the September 11th one, that's something for later, but it's these two. And so they're already should be here in the files. Portion of RStudio Cloud, and so if we just collect them, that'll read those in. CSV is a comma separated values, and it's just a file type, like a spreadsheet type file. And this will read them in and put them into terrorist nodes and terrorist links. One of the confusing things to me, probably the trickiest thing to me about doing this network analysis, is that you end up with a lot of different data sets. So you have the nodes and the links, and then you'll have the network itself, and you kind of have to juggle those and know which one you're talking about. But let's take a look at these. So we can take a look at in this case the terrorist node. So if we go ahead and send that to a data table so we can see it, these are terrorists who were involved in the bombing, I believe it was in 2004 in Spain. And it was one of the big terrorist attacks, in the years following 9/11 in 2001. And they killed many people on this train in Spain, and one of the things that happened is it was shortly before an election, and before the terrorist attack, the government was supposed to be reelected, but after the terrorist attack occurred, the government lost the election, and a lot of people have blamed the government's handling of the terrorist attack, and so it was, had a big impact on the country. So then after the terrorist attack, they caught most of these people and looked at the links between them. And so we have, you can see it says 64 entries. So there are 64 terrorists that they caught that were involved in this attack. And then the links between them are so we can look at kind of at the network here. Each one of these circles are one of those terrorists listed above. And then the links here, the lines between them were I don't know if they were emails or phone calls or other forms of communication that they found were happening, and again, they found after the fact, obviously, but you can see that some of the terrorists were more connected, like this one is only connected to one other terrorist, and some of them were connected to many other ones, and, you can kind of see that in the diagram. So we can also look at the links, and so I call those terrorist links. And so if we don't do the data table, this is how it looks. And you can see if we go back to the nodes, you can see there's a number, which is the ID, and then their name. And if you look at the links data set, that contains the links between them. So 1 was connected to 2 and 3 and 4 and 5, etc. But notice there's no link between 1 and 10, and if we keep on going through here, we can see 2 is connected with 3, but that's the only one, that's the only link that 2 has. 3 is connected with 4 and 5, but not 6, etc. So this is a big data set. You can see there are 243 links, and so those would be these lines here. So there's 243 of these lines, and what was it, 64, I think, of the circles. Okay, and I had kind of done this in advance, but what I wanted you to do is use this Viz network, and what you have to do to create this, so let's delete that here, is to put the nodes first and then the links into the parentheses. So it was terrorist nodes, I think that has to be first, and then the terrorist links second. And we'll talk later about how to make this look a little nicer and get some of the additional display factors here, but this is just a real basic network that we can generate. And notice, by the way, that it looks different. You can kind of zoom in and out like that, but if you click it again, it'll kind of produce a different network, each time, a different look to it. Yeah. And you can take them and you can, it's nice on a web page because you can, it's interactive on the web page. Okay. The other thing we need to do is we need to use this, in this case, we're going to use this graph from data frame to create the network itself, a representation in R of the network. And this is an iGraph command here. And so we give it the links, that's kind of the most important thing. And then in iGraph, what I was calling nodes before are called vertices. So like a vertex is this is a vertex or a node. And so we say vertices equals, and then give it the name of the data frame that contains the nodes. And it's not directed. And what that means, that means that the relationships are mutual. If it's directed, that means maybe there was a communication from, this terrorist to this one, and it might even have an arrow on there, and that would be a directed communication. What we're keeping it simple, and we're saying it's not directed, so any link between them is a mutual link. Okay, and so now, did I run that yet? So when we run this, this creates this terrorist network. And so now we've got these three things. We've got nodes, terrorist links, and then terrorist network. And so that's what I mean by it's kind of tricky. We have to keep straight which one we're dealing with. And actually, if we look at what this terrorist network looks like, I don't think that displayed. Let me try that again. There we go. It's basically showing the names and the links between them, and it has, I think these yeah, like 64 is the number of nodes and 243 is the number of links. So it kind of gives, I think this even means something that I don't remember, but so it's hard to interpret what all this what this means, but we're going to use this terrorist network to get some of the statistics out of the network. So let's do that now. So we can use this terrorist network, and one thing we can do is we can count the vertices. And so remember, in iGraph, what I'm calling nodes are called vertices. So we can pipe terrorist network into vcount to count the number of vertices, and so that should be 64. So if we didn't know that before, we could get that with this vcount command. We can count the edges or the links, and so we can do terrorist network and then pipe that into count, so that's edge count, and run that, and it should be 243. Yeah. Now we already know that, but you can imagine if you have a big network, it would be useful just to know that basic information about it. Here's something else, another statistic that you can get from the network. You can read this stuff, but basically the density of the network it's a measure of how tightly connected the network is. If it's tightly connected, the edge density will be very high. Meaning that if there's a lot of connections, like imagine a group of friends, I say here, let's say there's 4 people, and they're all friends with one another, then you're going to have the maximum number of links between them. But imagine that you have 4 people and there's only 3 friendships among the 6 possible friendships there are. Then that would have an edge density of 0.5. So density is the number of connections divided by the number of possible or potential connections. And so we can, and I kind of did the math here. With 64 terrorists, you can do the math here, and there's 2,016 potential connections among 64 individuals. But we know there's only 243, and so the edge density should be 243, which is the number of actual connections, divided by 2016, which is the number of possible connections. And if we do that math, it turns out to be 0.12. So if we don't want to do that math, we can just do this terrorist network, pipe it into edge density, and we should get, we get that 0.12. Okay, so that's another kind of a statistic that we can get out of the network. And so the higher this number, the more tightly connected the network is. The lower the number, the more loosely connected it is. Another thing we can get are the distances. The distances are the shortest paths between nodes. So in other words, like if we go back up to this diagram, so like this terrace is connected with just one hop, one link from this one to this one. But to get from this guy to this guy, that might be 1, 2, 3, 4, 5 or something, 4 or 5 or so hops. And we're going to just look at what is the shortest distance, the shortest number of links to get from one to another. And like probably the farthest is maybe from this one, maybe all the way down, maybe to that one. And so that might be, I don't know, 10 or something hops. And so basically that's what this distance is. Here we are. That's what that distance is doing. And so we can get the distances just with this, pipe it into that distances function, and then we can make a little data table of it that we can look around in. And so what this will do is it's this matrix, and it'll show you, so from this first one, Jamal Zugum, to this Muhammad Bekali, there's only one hop between them. So they're connected by one link. And by the way, you can see obviously the one is connected to himself by 0. But then you'll see other ones, like to get from this one here to this one here, it requires 2 hops. And then some of them will be, there's 3, and some of them will be higher than that. So basically what distances does is it gives us just a list of all of the number of links required to get from one terrace to the next. Now what we can do, it took a little doing here, but I can make a little histogram. I wanted to convert this bunch of numbers in a matrix into something that we can graph as a histogram with Plotly. And I had to do a couple of things here to convert it into some numbers that Plotly could understand. But basically what I'm doing is just going to create a histogram of all those numbers. So you can see it looks like the highest possible number of hops was only 6. And it looks like, there's a lot that are 2 apart and 3 apart, some that are 4. It's almost kind of a normal distribution, right? With 2 and 3 being the most common number of links. There's some that are really high that are far apart, 6, and by the way, they're even counting, and notice how there are 64 zeros, and that makes sense because that's each terrorist with himself, and so they're even counting those, that are counting them as zeros. So it gives you a sense of, again, how loosely or tightly connected the terrorists are. Okay, now the other thing we can do is we can get the mean distance. So it looks like it should be around 2 or 3, right? That's in kind of the middle of this distribution. So we can take our terrorist network and pipe that into mean distance. And okay, so this is a kind of a statistic that we can get out of the network that'll tell us, again, if they're tightly connected, this number is going to be lower because they're all kind of communicating with one another. If they're loosely connected and there's a lot of terrorists that are 10 or 20 maybe links apart, right, or something like that, then this number is going to be a lot higher. Okay, and then now another important statistic on the network is called the diameter, and so we can get, let's see, terrorist network and pipe it into get diameter. And so the diameter is the longest. So if we look, the diameter of a circle is, from one furthest point to the next across the circle. And so the diameter, it's probably like from here to here, right? Whatever the longest path is between any 2 terrorists, whatever that longest path is, that's the diameter of the network. Let's see, where was I? So we can run that, and it'll show us the exact pathway. So from this guy all the way to this guy, and it looks like there's 1, 2, 3, 4, 5, 6, 7, and we can actually get I guess it tells us the number here with this 7, but we can, another technique we can use is just do get diameter and then do length, and then that should be whatever the diameter is. So the diameter of this network is 7, and again, that's a kind of an indication of how big it is and how kind of loosely connected it is. Okay, so let's go back to VisNetwork a little bit, and one of the things I didn't do before is do a layout. So we have our Viz network just like we did before with our nodes and links in there, but then we're going to pipe that into another Viz network command called viz igraph layout, and we can define different layouts. So just to show you one example, here's one that creates a layout that's a circle. And so each of the circles along the side here are the terrorists, and you can see the connections, between them. Um, and then, okay, so it's telling me do two more below. So let's do viz network. And then we want our terrorist nodes was first, and then links, and then pipe that into viz igraph layout, and then say layout equals, and then in quotes it says do one with layout on sphere. I think I didn't do the equal sign correctly. There we go. And so let's look what that looks like. So you can kind of see it's trying to make it look, give it a little bit more of a three-dimensional look, you know, so a sphere. And then it says another one with layout on grid. So actually, I think I'll cheat here and just copy this. And it says layout on grid. Oops. Okay. And so that, you know, I see that's a grid like a matrix. So you can see there's different ways of diagramming the networks. The one that I kind of like, that's a fairly standard one, is this layout nicely. And so let's look at what that looks like. There we go. So it tries to kind of equalize the length of the lines, I think, and there's kind of an algorithm that it uses to create that diagram. Now, okay, so now here's one thing that we can do to improve this. I mean, one of the problems here is that we don't know what these nodes are. I mean, this is one terrorist, but who is it? You know, we don't know who it is. So one thing we can do is we can put the names so they'll appear there in the network. And so to do that, we need to get our terrorist nodes data, which again was this here, right? This is our terrorist nodes. And it basically is just the names with the numbers next to them. And we need to create a new variable in there. Here we are. That's called label. And what if we, as long as we have a column called label in our terrorist nodes, it'll show up in our diagram. And so when we run this, so this is just doing terrorist nodes. It's going to mutate, you know, so mutate creates a new column called label that's the same as the name of the terrorist. And then putting that back into the nodes data and then displaying it here. So one thing that's a little weird about this is it's kind of redundant, right? We have basically all I've done is taken the column called name and created a new one called label that has all the exact same names in it. But the only reason we do that is because this viz network requires a column called label in order to show the names. And so whatever's in label here, and we might do something different. We might, you know, only put in the last name or something like that. But in this case, we just duplicated it exactly. So now when we do it, so all I'm doing here is just running that exact same, I'm not even adding anything to it, it's the exact same viz network again. And it actually doesn't look like anything has changed, but if you kind of zoom in, there now you can see the names. And so below each circle, it has the name of the terrorist. And I guess it kind of doesn't show up, you can't read it if it was that distant anyway, so you kind of have to zoom in on it a little bit. By the way, this is interesting. This Muhammad Atta, he was involved in the 9/11 attacks. In fact, I think he was on one of the planes and killed in one of the 9/11 attacks. And so it's odd that he's in here when the Spain attack occurred, you know, several years later. But I guess he was involved in the planning of the Spain attack too. Okay, so all right. Now it also says we can create another column called title. So what I'm going to do is I'm going to start with this terrorist nodes, and then I'm going to replace it with another version. And so I'm going to do this mutate. So it says here, mutate yet another column with the names of the terrorists, this time called title. So I'm going to do mutate title equals name. And then, and in fact, I'll show what that looks like again. And it's even more redundant. So now we've got 3 columns all say the same thing. But in VisNetwork, what will happen is title will appear differently. Okay, and it says after creating the title column, go back up to the diagram and run it again. So let me show you what happens here. So notice, okay, if I have my cursor over the circle, nothing happens right now. But now when I run it again, so I've got that title in there. So now if I hover, it pops up the name. So that's all that does. So the label makes it so it appears there when we zoom in on it. If we don't want to zoom in on it, if we just want to hover over it, that's what the title column will do. Okay, so just 2 different ways to display the name. Okay. Okay, now here's something else we can do. It says this Viz options. So what I'm going to do is do a new line. I'm going to pipe this into Viz options, and I'm going to do highlight nearest equals true, and create the diagram again. What did I do wrong here? Oh, Viz options. There we go. See if that fixes it. Yeah. So okay, so now what we do, if we what that means is when we select one, it will highlight all of the connections. So now we're looking at this terrorist here, and he's got a lot of links to other ones. Whereas like if we click on that guy, there's only a couple, right? There's only those 2. I actually don't know why it's highlighting these lines here. It's interesting. Anyway, so you can kind of see it's just another way of kind of examining a little part of the network. And if we click outside of it, it'll highlight them all again. Okay, so that's what the highlight nearest option does. Here's another thing that we can do. It's called node selection ID equals true. And so right under Viz options, we can say there we go, node ID selection equals true. And then when we do that, so node ID selection, we can select here. So we can go through and let's find that, Muhammad Atta again. There he is. And so now it's just another way of selecting, rather than looking here visually for it, we can scroll through the list and look at the names. Okay, so that's just another option we can use. And then we want to add a title. So what I did here is I write in, we need to put that right in the main VisNetwork call here. In parentheses, we just put main equals, and then in quotes, the title. So I put network of terrorists involved in the 2004 Madrid bombing. And so there you get the title. Okay, and it still has that other stuff. It has the nearest selection, and it has the select by ID up here. Okay, so a couple of other things about the network. So here's one thing that we can look at. It's called the degree. And so I'm going to create a new chunk here, and I'm going to take the network. I'm going to pipe that into degree. And so degree is the number of links each individual has. So again, we can kind of look here and see, like this one will have a degree of 20 or whatever that is, whereas this one will have a degree only of 1, I guess, because there's only 1 link. So it's just a way of seeing how connected each individual is. So when we go ahead and run that, yeah, in fact, that one, I think that was the same one I'd selected before, that it actually has 29, whereas some of them will only have 1 or 2, and it kind of gives a sense of the importance probably of that individual in the network. And so what I say is this is an important enough measure that we might create a new variable out of it. And so what I'm going to do here is I'm going to take our terrorist nodes data, and I'm going to mutate, so create a new column called degree that's based on the degree, of that of the terrorist. And so, and I'm going to put that into nodes, and so we can, and then I'll create a little table of it, and so now we can see, and there's our funny thing where we've got the three columns exactly the same again, but here's degree. And so notice that I think that this data set was already sorted by degree, right? Because the highest, this Jamal Zugum, was the highest number of connections. By the way, I think this was the guy who owned a mobile phone shop in Spain. And so probably maybe one of the reasons he's so highly connected is he gave everybody the phones and talked to everybody. But you can see, you can kind of scroll through and see it decreases. Some of them have as, whoops, again, as high as 29, and other ones maybe only have one. Now we can look at the distribution of the degrees of each of the terrorists with this add histogram. So we're going to start with terrorist nodes, send that to Plotly. We're going to look at degree as a histogram. And this, there we go, it should look a little different. Now this will not be normally distributed, right? Because we have a lot of the terrorists that only had, a link with oh, that's 0 to 4. Okay, so I don't think anyone can have a degree of 0, at least in this network. Everyone had at least one connection, but this is 0 to 4, and most of the terrorists had, so 24 of them. I guess that's not quite most, but a lot of them had somewhere from 0 to 4, so a low number of links, and a few of them had above 25, like that Jamal was one of them, had 29. Okay. Now, one thing that we can do is if we set in our terrorist nodes, just like we set a label and a title, we can also set another column called value. And if we set something called value, then when we diagram it, the circle size will change based on the value. So what we want to do is set value to degree. And in fact, okay, I'll just run the whole thing. So what this shows here, so you can see now that some of the circles are bigger than other ones. And there's that Jamal who had that 29, and so he's got a bigger circle. He's got more connections. And whereas this guy only has one, and so that he's got a little circle. So kind of, it's just a way of kind of diagramming it so that you can easily see kind of how important the different individuals are. So another measure is closeness, and it's you can read this. It's considered to be a measure of the centrality in the network, and it's basically how. So it says it's a measure of how many paths each other node would have to take to get to that node. So it's kind of like how close it is to all the other ones in the network, and so we can send network into closeness. Try that again. There we go. And you can see each name, and then it has, it's hard to know what that number means exactly, but basically the larger the number, the more connected it is to the others in the network. And so what we could do is we could, instead of setting value equal to degree, we could set it to closeness. And so what it will do is change the size of the circle in the diagram to closeness rather than to degree. So it's just another kind of statistic that we could use. And I'll show you if so we'll do that. And then now you can see here's our nodes data are getting larger, right? We've got those 3 based on the name. Here's degree. And now we've got closeness, and then we've got the value set to the closeness rather than we had it set to degree before. And so now, if we run it, So now we've got this value which determines the size of the circle in the picture. Now we've got it set to closeness, and I bet degree and closeness are very similar, so it probably won't look that much different. But anyway, it's another statistic that we can use to manipulate what the picture looks like. Now, okay, so here's another one, and it's called betweenness. So we've got some of these. We've got degree and closeness and betweenness. The difference with betweenness is that it applies to links rather than nodes. And the idea is, it's kind of, I kind of make the analogy here, if it's a common road, then it would have high betweenness because people have to use it to get from one area to another. And so if we kind of look at these here, you can imagine, like, this is, or let's say this one here, this link here is not, the only one who would use it would be this guy here, right? Otherwise, it's not going to be used very often. And on the other hand, one of these other ones in the middle down here, let's say, I don't know, to pick a random one, maybe one in here, they are probably going to be used a lot, because if this guy wants to communicate with this guy over here, it has to go in between one of these lines here. So anyway, it's another kind of a statistic of a network that will, in this case, apply to the edges, or the links, rather than the nodes. And so, sorry, I'm kind of moving here. And so if we run this, we can get, it's called edge betweenness, and we pipe the network into edge betweenness. And then it's a big mess of numbers, but basically it's a measure of, again, how often one of those links is used. So what we can do is, this is going to be a little trickier, but we're going to take our terrorist links data and we're going to change it. So what I'm going to do is mutate a new column, and I'm going to call this one value. But notice, okay, so now we're in the links rather than in the nodes. And so I'm going to say value, let's see, what am I doing here? Yeah, I think that's right. I think so value equals, and then it's this edge betweenness. And then of the terrorist network. And that's the tricky part about it. You got to keep straight which one you're dealing with. So let's see, and then I think I'll display it and make sure I did that right. Okay, yeah, so there's our links, or there's our from 1 to 2, 1 to 3, etc. And now we've got this value that's based on betweenness. But I think it wants me to add, I think I did something wrong there. So what it wants me to do is add a column called betweenness. So let me do that first. Let me start this again. So what I'm going to do is I'm going to call this betweenness. And then I'm going to mutate another column called value that's equal to betweenness. Just so we have it labeled properly. So let's try that again. Yeah, okay, that's what this is telling me to do. So I want one column called betweenness, just like we had degree, and then another one called value that's based on betweenness. And so now what happens when, okay, so now we've called one of these columns value in the terrorist links data. And so look what happens when we run. This is just the exact same graphing command that we did before. But now what should happen is, notice that some of these lines are thicker. So if they're commonly used communication routes, then they're thicker. And so, obviously this is really important because, imagine you're studying this and you're trying to track down a terrorist network, and you want to find where the important communication lines are so you can try to, break them. whereas this one is a thin line because it's only a link between those two. Okay. All right, so now one last thing I want to show you is what are called communities. And if you look at the network here, you can see there are kind of clusters, like there's this cluster here that communicates, a little cluster here. Those are called communities in network analysis, and we can use iGraph to find these communities using a statistical algorithm. And so there's a couple of algorithms that will detect communities. The one we'll use is called InfoMap. And so all we need to do is send this terrace network to this infomap.community function. And then this keeps on happening to me where it doesn't display it correctly. There we go. And it'll have, so it looks like it found 6 groups. And you can see, so it's not showing all of them, but here's group 1, and it has the members of group 1, and then group 2, etc. And so to display this, to display the group that each terrace belongs to, we can use this what's called membership. And so we're basically just going to do the same thing we did before, infomap.community, but then pipe that all into membership. And what it should do is it should show us each terrorist and then which group they belong to. And I guess there were 6 groups, and so you can see which ones belong to 1, 2, 3, etc. So then what we want to do is we want to take that information. So I'm going to take this membership of this community, and we can do that with this kind of set of commands here. We're finding the membership of the InfoMap community of the network, and we're going to put that into a new column under nodes called group. And so when we do that, you can see here's our nodes again with the names 3 times and everything, but now, where is it? Let me show you a trick that you can do if you're not seeing it all. You click this little button here and it says show in new window. Let's see if that was the problem. Maybe the window, yeah, there it is. It was just at the very end, and so we couldn't see it in our studio. But you can see here, this tells us which group each of these individuals belongs to. And so we can kind of sort that, and we can look at them, and we could search and do all kinds of things and see. You can see it looks like there's only 2 individuals in this 6th group. I think it kind of ranks them by importance, so the last one is the least important. Now, okay, so now what we can do with this is we have this group column here. There it is, okay? If we stretch it out far enough, we can see it. And when we run this viz network again, this is another case where it'll automatically take whatever we've called group, but we have to call it group. But if we have that column, it will automatically put that into the network. So again, I'm just showing here, it's the same command that we used to create the network above, but look what happens now. It colors them by group. And so you can really easily see which terrorists are in which groups. And you can see that green one, they're kind of connected here. There's a purple one that's over here. And again, it has a statistical way based on how tightly they're linked of calculating how many there are and which ones are in which group. Now, there's one last thing. So what I think I'll kind of cheat here and copy this network. I wanted to show you one last thing you can do. It says here inside viz options add selected by equals group. And so I'm just going to do selected by equals and then in quotation marks group. And when we do that and run it, notice that we have a new drop-down menu command here that has the groups. So if we want to look what is group 3, then it will, and it does this highlight nearest again, so it'll display just those from that group. And there's another one, etc. Okay, so I think that's it. I want to just mention that with this assignment that I want you to publish, I wanted to give you an option. So option one are the September 11th terrorists. And so basically it's the same, pretty similar to what we just did above with the Spain terrorists, but instead with the September 11th terrorists. But I wanted to give you, in case you're, sick of terrorists or want to do something different. I had this fun data set that's based on one of the books of the Game of Thrones books, and so if you like those that TV show or those books, it's if you know about the Game of Thrones, there's all these different families and factions and stuff, and so we can make a little a network diagram and do some network analyses of the Game of Thrones connections in the book. All right. I think I'll make one separate video about each of these. So I'll make two videos, one on each of those two. All right. Bye.